Good morning, boys and girls. Okay, in the previous video, we have seen uh, what is volume. Okay, and so let us revise it. So, volume is the space occupied by a body, that is called its volume. Okay, or the space in a container is called its capacity. So, now volume is a three-dimensional quantity. So it has three dimensions: length, breadth, and height. Okay, so that's why its unit also is uh, always a cube. Okay, so its standard unit is SI unit, m cube or meter cube. Okay, now there are these some multiples also. So I had already explained, you better learn them. Okay, now about area, area you already know. It's a two-dimensional quantity. That is, we have a length and we have a breadth. So now you know the formula for square side into side and rectangle and with breadth, and that's how now the units. Okay, standard unit is 1 meter cube. Again here, now there can be some multiples for smaller quantities: centimeter cube square or millimeter square, and the conversions. So you should remember the conversions also, and the bigger units, hectare or kilometer square. Okay, and their conversions. Now we had seen how to find area of irregular shape. Okay, on a grid. So just by counting the number of squares which are complete squares inside the irregular shape, this shape. Okay, so first you have to find the complete squares, count them, and then the squares which are touching this boundary, or which they contain the boundary line. Okay, all these squares which contain the boundary line inside them. So now just they are complete squares. So if it is 1 centimeter square, one square, then just multiply by 1, and these will take it as half. So count these squares and divide by half, 1 upon 2. You know, divide by 2 or multiply by half. Okay, that's the same. Or multiply by 0.5. 0.5 or 1 upon 2 is same. Or in other words, you can say just divide by 2. So then how to find? First count these squares, then suppose here complete squares are 38. So right here, then the boundary squares are 29. So either you multiply by 0.5 or divide by 2, that is the same. So you will get whatever you get, you add 38. Okay, so 38 plus 29 into 0.5 is how much? That is 14.5. So add 38 plus 14.5, that is 52.5. Now look at the second example. Here is also a regular shape given on a grid. So now mark the complete squares inside. okay, inside the boundary of this figure. Count them and write them. Okay, they are equal to 1 centimeter square each. So as many squares are there, that becomes that many centimeter square. Now the squares which contain the boundary line, count them again. Okay, and divide by 2 or multiply by 0.5, that is the same. And the complete squares are 49. So 1 square is 1 centimeter square, so that means 49 centimeter square. Now boundary squares are 41, so divide by 2. So if you divide by 2, you get 20.5. Now add them together, 49 and 20.5. So that is 69.5 centimeter square is your area. Now we come to the new topic, measurement of regular solids, measurement of density, okay, of regular solids. So what is density? Density is the ratio of the mass of a body to its volume. Okay. So by knowing the density, we can compare the substances which is heavier or which is lighter. Okay. If we take equal volume of different substances and we know the density, we can tell which is heavier and which is lighter. Okay, now how to find density? So there we have to find mass and volume of a given substance to find the density. Okay, so density is represented by D, and the density can change with temperature also, okay, and with pressure also. So we always take density at a given temperature and pressure. Okay, now why it varies? Suppose you heat a substance, as you know, it expands, so volume changes on heating anything. When the volume is changing, the density also changes. Okay, so that's the effect of temperature on density. Same with pressure. If you can compress a substance which can be compressed, like gases can be compressed, so their volume decreases, so the density increases. Okay, so temperature and pressure have their effect on density, so they need to be considered. Except water, all substances density decrease on increasing the temperature. When you heat an object, a substance, the volume increases usually. Okay, so when volume increases, density decreases, but water is a different case. I'll tell it about it also. So, because water, when we heat, its volume increases, but if you decrease the temperature, when it comes to 3.98 degrees Celsius, it has the maximum density. Okay, when you go below this temperature, water again starts expanding. The volume again starts increasing, and above it also it increases. So it's a different case, water. So we take water density of water at this temperature as 1 gram per centimeter cube. Okay. So water has maximum density at this temperature. So it's an exceptional case, but others follow the same rule. Okay, now units of density. Standard unit or the internationally accepted unit is kilogram per meter cube. This is written as m minus 3, but okay, this is better to read kilogram per meter cube. You can write it like this also, kilogram per meter cube. Okay, or like this also. Okay, they are the same. Okay, so this is kilogram per meter cube. You can write it like this also. But kilogram, but smaller units in CGS system, this is 1 gram per centimeter cube. Okay. Now how to find density, okay, of a regular solid? So we know, we have seen in the formula. We need to know two quantities, that is mass and volume, to find the density. And if you divide mass by volume, you get the density. But the units, you have to check the units. They should be either in kilogram meter system, okay, kilogram and meter cube, or gram and centimeter cube. Okay, now here is an example given. If you have a rock with a volume of 15 centimeter cube and mass 45 gram, what is its density? So we know both the quantities. So, and both are, this is in CGS system, so units are also correct. No need to change them. Now we can find the density. So divide mass by volume. So that is 45 upon 15. So 15 3s is 45. So 3 gram per centimeter cube is the density of the rock. Okay, now the second example. 96.5 gram of gold has a volume of 5 centimeter cube. Now find the density. Again we are given mass in grams and volume in centimeter cubes. So there is no problem in units, we can divide. So divide it and you get 19.3 gram per centimeter cube. So that is the density of the gold. Now look at third example. Now here density of diamond is given 3.5 gram per centimeter cube, and what would be the mass of a diamond whose volume is given 0.5 centimeter cube? Here we have to calculate mass. So mass equal to density into volume. This is the formula. Okay. So multiply density and volume. So check the units. Units are in gram and centimeter, so we can multiply them. So 3.5 into 0.5, that is 1.8 gram is the mass of the diamond. Now next example. 96.5 gram piece of aluminium has density of 2.7 gram per centimeter cube. Now you have to find the volume. So formula for volume is mass upon density. Okay. Now divide the mass by the density and you get the volume, which is 35.7 centimeter cube. Okay, now so you can find density, mass and volume if it's given, and so there are three quantities in this formula: density equal to mass upon volume. So if mass and volume are given, you can find density by dividing, and if you have to find mass, then take volume this side. So density into volume equal to mass. Okay, this is the formula to find mass, or you can write mass equal to density into volume. And if you have to find volume, then take volume to this side and density in place of volume. So that becomes volume equal to mass upon density. Okay, so these are the formulae used here. And we have numericals also in this chapter. So just remember this formulae. And if you just know this formula, you can convert the formula for others. Okay. So now in the next video we'll see what is speed. You know, in maths also you have studied what is speed and the formula of speed, and units of speed we'll see, and also some examples and numericals we'll do, okay, in the next video. So just do the reading. Okay, so read it again, the density from so if you read, then only it will be clear to you, and also some words, technical words you have to remember. So go through these pages, and this also speed also, then you will understand better in the next class. Okay, so that's all for today. So read the chapter, and also you can try the numericals given at the back.